your integers equation, your integers worksheet. Integers worksheet. Hold them up and let me see them. Yay, yay. Good, 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 good. Come on, Cameron, speed it along. Good, Dakota, good, 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 good. Good. All right. Are we ready? I am going to be checking the left column. This. Yeah, we're going to go over the left-hand column, okay? You ready? Number 1, negative 121. Mark them wrong, okay? Number 2 is 33. Number 3 is negative 6. Number 4 is 75. Number 5 is negative 11. Number 11 is 19. Hold on one sec. What period are you, honey? 8th. What period are you? Oh, you're not mine. Sorry. You're welcome. All right. What number are we on now? On 12? 12 is negative 71. Number 13 is negative 80. Number 14 is 75. Number 15 is negative 35. How did we do on 1 through 5 and 11 through 15? Who missed 0? Booyah. Who missed 1? Okay, 2? I'm cool with all that. 21 is 12. 22 is negative 56. 23 is 0. 24 is negative 77. 25 is 66. Who missed 0 on that section? Awesome. Next, 31, negative 7. 32, negative 12. 33, 6. 34, negative 6. 35, negative 5. Who missed 0 on that section? Any questions? Okay. Pass them over to Cameron and he'll put them in the bin for you. Thank you. That's what you get for getting yours out last. Over there. I'll be grading the right-hand column. Should be a good grade, right? It'll be worth 20 points. All right, get out your equation worksheet. Your equation worksheet. Let me see them. Up, over. Eek, eek. You didn't like my fractions? No one likes my fractions. No, I said to attempt them. It's your fib. Tell it the way you want it. Hey, you don't have your wingman in here this year with old Luke helping you out, so I don't want to hear it. You just have 3 other goofballs as wingman. You're right, there is way more than 3 goofballs. That's priceless. All right, here we go, spot check. Please listen. I'm not going in order. Number 2 is 36. Number 6 is 7. Number 7 is 25 over 4, or 6 1/4. Number 9 is 15. Number 10 is negative 6. Number 11 is 13. Number 14 is 3. Number 16 is 5. Number 18 is 1 over 7. How many of you had 7? Quit letting your brain do that. You flipped it. You totally flipped it. You said 196 over 18 instead of 28 over 196. Okay? You totally flipped it in your brain. Don't do that. Number 19 is 4. Turn it over. I'll give you all the answers. Are you ready? 21 is 33 over 5. Yay! Number 22 is negative 22 over 5. I got somebody who's gotten both of them right so far. Ashley. 23 is negative 46 over 19. That is math. 24. Well, I'm not. Well, do it once. Go ahead and convert it and give him an improper fraction. See what he does once. And 24 is 75 over 4. Who got all 21 through 24 right? Mickey Wise, I am so unbelievably proud of you right now. Oh. Mickey. Brian. Get rid of that candy bar right now, young man. Not everybody has ungodly long arms like you. Totally snag that in midair. Wrong. Again? Okay. Go ahead and tell me. What's up? Come on in, Tanner. We already went over all the worksheets. You can't help it. Computer Tech Prep just got here, huh? Okay. Here's the deal. You don't know how to do the back, do you? All right, before I do that, are there any questions on 1 through 9? 1 through 9. Going, 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 gone. Okay. Any questions over 10 through 15? Going, 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 gone. 16 through 20. Going. Absolutely, hon. Number 18. Your brain totally messes with your head. All of us have a little bit of dyslexia. No joke. Every one of us. Because our brain will flip things around on us whenever we don't even realize it happens, okay? You transpose things. You transpose numbers, letters, and also numerator and denominator, okay? Your brain knew, okay, we're going to go ahead and divide both sides by negative 196. A negative divided by negative is a positive. Your brain did that, okay? But what your brain screwed up is that it wanted to go ahead and keep the whole concept. It wanted to switch this around because 196 divided by 28 was 7. And you tried to say, okay, well, this bad boy is equal to 7. Because 28 times 7 is what? 196. But that's not the problem. So to go ahead and eliminate doing that, go ahead and write 28 over 28 times 7 is equal to x. Because then you can see that the 28s are over top of each other and what happens to them. A little bit of cancelage going on there, and I have 1 over 7 is equal to x. Does that make sense? Okay? If you don't have to do this step, you don't have to do it. But if you know that you are that type of person who is going to flip your numerator and denominator wrong, go ahead and take that extra step. You get me, folks? Questions? Does that make sense? Okay. So are we good on 16 through 20? Gone. 21. Two-thirds times 5x minus 6 is equal to 18. 2/3 times 5x minus 6 is equal to 18. Now, folks, the question I'm going to ask you, look at the denominator. What is the denominator? A 3. Well, now you're going to go ahead and you're going to go inside, which is the 5 and the 6. You're going to put that over 1. Because you're going to ask yourself, is the junk inside the parentheses divisible by the denominator? Is 5 divisible by 3? Is 6 divisible by 3? It is, but it doesn't help us to distribute the 2/3 because both of the things inside the parentheses are not divisible by them. You get me? So what we're going to do is we're going to make this thing look pretty. Right now it's ugly, right? We're going to make it look pretty. The way we're going to do that is by multiplying by the denominator. So we're going to take and we're going to multiply both sides by 3. Because we don't like ugly things. We all have our ugly days, but we really like to have beautiful days, right? So we're going to go, we're going to multiply, distribute that in. This 3 cancels out with that 3 here whenever we distribute. Do not distribute it into the parentheses, because if you do, you're multiplying the 2/3 by 3, and then multiplying the junk inside by 3, which means you are actually changing the problem and multiplying by 9. You get me? We don't want to do that. Okay? So what am I left with? I am left with a 2, and I'm going to recopy the junk inside the parentheses. I go across the equal sign, and I'm going to take 3 times 18, and that gives you what? 54. Tell me, folks, does that look pretty? Does that look pretty? Can you do that now? Does that make sense? Now, is it going to bother anybody if I do not solve this right now? Because I'd really like to utilize our time in not solving the equations that I know you can solve, but by utilizing them and getting them pretty. You get me? So does anybody want me to solve that? Okay, are we good to distribute 10x minus 12 is equal to 54? We good? Okay. All right, now let's go ahead and make 22 look pretty. 5 over 6 times 8y plus 10 minus 17 equals negative 38. What's the difference between this problem and 21? Christian, what'd you say? There's another term over here. More importantly, that term is this right here, right? I don't like that term there. What do I do with it? If you don't like it on the left-hand side, how do you take it over to the right-hand side? Christian's exactly right. You're going to add it to both sides. So all you're going to do is add 17 to both sides. And when you do that, what do you get? Working from left to right, 5 over 6 times 8y plus 10. That cancels is equal to negative 14. The signs are not the same, folks. No, it's not negative 14. Sorry. I looked at my wrong problem, and I was thinking another one ahead. I apologize. Negative 21. My paper doesn't look like yours. See? It does, but mine doesn't have any of the back. I apologize for that. Okay, now, it's still ugly, isn't it? It's still ugly. So look at the parentheses. 8 over 1, 10 over 1. Is 8 completely 100% divisible by 6? No. Is 10 divisible by 6? Well, we could have stopped right whenever we said no to the 6, right? Or the 8, sorry. So tell me, what am I going to do? Multiply by what you want to get rid of, which is the denominator. Yes? So when I distribute, 6's are gone. I'm left with a 5. 8y plus 10 I bring down. I go across. What's 6 times negative 21? Negative 126. Yes? Does it look pretty? Who's getting this? We getting it? Do we understand what I want you to do? Is it easier this way? Okay. You're going to go ahead and distribute then, yes? Okay, shall we do 23? 23. Negative 2/5, 3x plus 12 plus 32 plus 5x is equal to, oops. Your computer wasn't working. Is equal to 18. What's different about this one? There's 2 terms on the left-hand side with the parenthesis. So what are you going to do? take both of them over. So I'm going to take and get rid of the 32, and that's going to be subtracting 32 from both sides. That's gone. Negative 2/5, 3x plus 12 plus 5x is equal to negative 14 now. See, I told you I looked at the wrong problem. Okay, now what? Move the 5x over. Thank you, Cameron. Move the 5x over. How am I going to do that? Subtract 5x. Negative 2/5 times 3x plus 12. 5x's are gone, is equal to negative 14 minus 5x. Everyone good? Yeah. Because then you're going to have to FOIL to two different terms with the one being a parenthesis, which you absolutely could, and it's not wrong to do that. It's just easier sometimes whenever you have the junk that's ugly to stay on one side to kind of isolate that and to deal with the other. You absolutely could leave it there, and if you choose to do that, it would not be wrong whatsoever. Okay? There's always another way to do this, and I am never opposed to you doing it that way as long as you get the right answer. Okay? Any questions on that? Now at this point, you want to go ahead and put parentheses around this before you multiply both sides by what? Why by 5? Because that is your denominator. Who said negative 5? Christian, you're more than welcome to multiply by negative 5 if you want. It doesn't matter. Okay? So the 5's are gone. Negative 2 times 3x plus 12 is equal to, I'm going to bring that 5 in front. Why did I do that? Why did I put the 5 in front? Because you guys like the distributive property generally seen on the left-hand side rather than the right-hand side, correct? So just out of comfort for our eyes to view it that way, I put it on the left-hand side. And then you're going to go ahead and distribute and combine like terms and all that jazz. Do we feel like we get it? Yes? Okay, now understand something. I did these for you, didn't I? I showed you how to make them pretty. And it looked really easy right now. You need to make sure you know how to do this on your own. So what I highly, highly, highly recommend doing is tonight, whenever you have no homework from me, just saying that, to go ahead and maybe nail these out by yourself, write them down on a separate sheet of paper, and see if you can get these answers by yourself, okay? Without hearing my voice, without seeing your notes, and figure out if you can do them. Because if you can do them by yourself, then that means you got it. If you can't do them, then you need to redo it until you can. Does everybody understand what I just said? We feeling good? The last one on 24 is actually a pretty easy one, right? 24 looks like a cinch now compared to like the other ones. Agree? Questions? You don't like it, Christian? Do you want me to do it? You want me to do it? Okay. Don't ever be like, no, I don't understand it, or, you know, don't say anything. Go ahead and ask me. Okay. What would you do? What would you do? Look at the stuff where? Where should your eye go to? Your eye needs to go to the denominator first here, looking at that, seeing the 7. Then your eye needs to go inside here and say, oh, okay, well, now what do I do? They're not divisible, are they? So I need to go ahead and do my rule. Multiply by what? I'm going to multiply by 7. So I have 4/7, 2/3 y plus 5 is equal to 10. That cancels. I'm left with 4 times 2/3 y plus 5 is equal to 70. Now what's throwing you off, Christian, is the fact that I have another fraction in the inside, correct? Don't freak. Go ahead and do what with this number on the outside? Make it a fraction. Go ahead and put that over 1. Multiply tops. 4 times 2 is 8. Multiply bottoms. 1 times 3 is 3. Do we all see that? Bring down that y. 4 times 5 is 20 is equal to 70. Does that make sense? Because now, how am I going to get rid of that 20? You're going to subtract 20. 8/3 y is equal to 50. Now how do I get rid of the 8/3? Multiply by the reciprocal, or multiply by 3 and then divide by 8. Either one will work. If I multiply by 3 and divide by 8, you're good to go. Does that make sense, folks? Yes or no? Okay, we good? All right, great. Go ahead and put that aside. What I want you guys to do actually tonight for homework is go ahead and correct that. If you messed up on things, go ahead and correct it and figure out what you did wrong. And work on those last 4 problems again, okay? So don't hand that in. Go ahead and hand that in to me tomorrow. Questions? Get out your notes. The pink sheets. Are there any more salmon sheets? If you have more salmon sheets, go ahead and put them in the bin. Any more pink sheets? Now, listen up. Make sure if you're going to hand this in that you go ahead and hand it in, put it in the bin, but make sure you post also to the website. Does everybody understand what I just said? So go ahead and put the pink sheets in the bin, and don't forget to post to the website because I did approve everybody, okay? All right, here we go. Exponents. You are going to love it. It's some amazing stuff right here. Math is so much fun. I love it. Where is my worksheet? Where is my worksheet? There it is. La, 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 la. Yeah, that's the bad thing about me recording. Everybody gets to hear me sing and do all the goofy things too. I don't mean to. Yeah, probably not a good thing. No, he doesn't. Huh? My hippo song is so wonderful. I wonder where my hippo is. Thieves. Okay. Now, for my Algebra 2ers that I had last year, there's what, 3, 4, 5, 6 of you in here from last year? Now, are we listening? If you, or 7 of you. If you don't get it, please ask me, okay? You know me well enough by now to just stop and ask me. The rest of you don't know me well enough yet. So you guys, I'm going to be constantly asking for a visual or verbal cue that you get it. My other ones already know they have to do that. So if you are not getting this, please, please, please say, slow down to me, make that little motion, or say, I'm not getting it, or say thumbs down, or say, I don't get it, Mrs. Yoder. I need to know some way, somehow, okay? All right, rules for exponents. For every real number, for every real number x and exponents a and b, the following is true. Now this is all the rules. If you check out above the computer back there is a red poster. That has the negative exponent rules. If you check out over here, the green poster by my filing cabinet has some of the other rules there. If you have the same base with 2 bases being the same with 2 different exponents, if they're attached by multiplication, like in case 1, you're going to add the exponents. So in exponent world, multiplication is actually addition. Okay? When they're attached by division, the 2 bases that are the same with 2 different exponents, you are going to subtract those exponents. Makes sense. So multiplication, the exponents are added. If they're division, the exponents are subtracted when you have 2 of the same bases. The difference between 1 and 2 and 3, number 3 has only 1 base. You get me? And that is your power to a power. In other words, it's 1 base with 2 exponents, but that exponent is being raised to another exponent. So what you're going to do is multiply those 2 exponents together. Everybody get that? The fourth one says anything raised to the power of 0 is 1. Perfection. Makes sense? Please don't forget that. I will get somebody. I won't mean to, but it will happen. So do not mess that one up. Anything raised to the power of 0 is always and forever 1. I don't care if I have the entire alphabet there. Okay? The entire alphabet does not matter. It's where is the exponent. Now, number 5. 5 and 6 are my negative exponent rules. Are we listening? If you have a negative exponent and its base is located in the numerator, to have that have a positive exponent, you are going to take that base only with that exponent and move it into the denominator. If it had a negative exponent in the denominator, to make it a positive exponent, you are going to slide it up to the numerator. So it goes in the opposite place of where it currently was and changes to a positive exponent. Okay? Number 7 talks about, well, what happens whenever you have more than one base? Well, if you have more than one base, you are simply going to distribute the exponent to each one of those. That's all you're doing. Okay? So, yes, these are just rules. They're just rules until we actually do some problems. So, I'm giving you your worksheet, and we're going to start it together. Understand that tomorrow you guys are going to finish it in class. Okay? What I want you guys to do tomorrow is make sure that you work as a team. If somebody needs help, you help them. I don't want anybody. I love that shirt. Math is functional. I love it. I need that. I'm sorry. I just saw it. If somebody needs help tomorrow, help them. Nobody is sitting single. You with me? If you see somebody sitting single, somebody who is outgoing, maybe needs to go hang with them and help them. You get me? I'm just saying. Here we go. Number 1. Now, all of you guys, all of you guys have seen this at one point or another. I'm going to tell you my way that I teach it. That doesn't mean you have to follow it, but I'm going to show you the best way that I think this is. With multiplication, you can rip and tear things apart and order them in any way that you want. So you're going to hear me say numbers with numbers and letters with letters. Numbers with numbers and letters with letters. I sing it to you all the time to make you remember it. And as I'm saying it, Billy is cringing because he remembers it far too well. Now, are there any exponents outside of the parentheses? No. Since there are not, everything's attached by multiplication, so I'm going to rearrange. Numbers with numbers, U's with U's. Do we see it? Now my brain has 2 separate problems. The first one is negative 7 times 5, which would be negative 35. U to the 2nd times U to the 8th. How are they attached? By multiplication. So in exponent world, what do we do with the exponents? You add them. So U to the squared plus 8 gives you negative 35 U to the 10th. And you're done. Make sense? Yay, nay, visual, verbal, need to know. Okay. Number 3. Number 3. Do I have any exponents on outside of the parenthesis? Am I still blinking? Okay. Do I have any exponents outside the parentheses? No, there's no exponents being raised, or the parentheses being raised to a power, right? So I'm going to yank it apart. Numbers with numbers, A's with A's, B's with B's. And I understand that you may not have been taught this way, and I understand that you may not like this way. If you want to do it differently, that is your choice. I apologize if this confused you. However, this has to be a review, okay? Now, here we go. I have 3 individual problems. I see what? In the first parentheses. A negative exponent. Mama, don't do negative exponents. So what we're going to do is put that bad boy over 1. And we're going to get rid of the negative exponent by doing what? Moving her on down. So 5 cubed goes to the bottom. That cubed, instead of becoming negative, becomes positive. Now what about the negative 25? But it's negative. The exponent on the negative 25 is a 1, folks. Do y'all see that? So it stays exactly where it is. That says that you owe somebody $25. My smartboard is not having a very good day. Now, I'm going to keep on going with this because our mind is already working on it, right? So what is 5 cubed? 5 times 5 is 25. And if you have 5 quarters in your hand, you got $1.25. So what does negative 25 over 125 reduce to? Negative 1/5. Wasn't that wonderful? We have one part of it already done. So I'm going to scroll back up. And I'm going to deal with my A's. Dakota, is this like Comedy Central for you? That's good. What do I do with my A's there? How are they attached? By what operation? Multiplication. So what do I do with exponents? Add those bad boys. So that's going to be negative 2 plus 1 to give you a to the negative 1. Now, extend, because what do you notice? It's negative, so I'm going to yank that bad boy and put her down south to make that negative 1/5 A. Yes, the A is in the bottom. The A is in the bottom with the 5. Go on up. I'm going to call you Mr. Positive this year. What do I do? Which is why we're reviewing. What do I do with my B's? Add the exponents. So that's going to be B to the negative 1 plus negative 4, which is B to the negative 5. And lo and behold, there is what? It needs to go down south to give you positive. Do we understand? Are you DHO too? Man, you guys are killing me. Tell her she has officially killed me today. That's good. That's my point. Do you understand? Do you know how many interruptions I've had? Do we understand this? Have a good day. You guys can do that tomorrow. See ya.